So that's going to get us and kind of shift gears. So that's about where most PDCs, that was about all you got for patterns, because most people don't want to talk about patterns, guys. My PDCs I went to, that was it. They had 20 slides, boom, done. Next. What is there more to say? Well, we know there's patterns. What do they do? How do we convey their meaning? And it gets a little bit difficult, but we're going to try. So this next little section, we're going to call it pattern understanding, recognition, and application. So how can I recognize them? So I need to be able to label them. I need to be able to communicate with myself. And I then need to be able to figure out how to apply the recognition. The passing of time makes a pattern. Understanding the seasons and how they affect what we do. So whether it's our compost regime, okay, whether we want to appreciate spring and furrows, maybe I want to know when the mushroom season is, right? These type of things are going to help me to understand when's the first frost, right? So from my gardening, when's the first day of spring, so I can start my seedlings indoors to have that earlier. And if I can get them started 2 weeks earlier, and I can ward off that first frost with maybe a cloche system, I could double my production that year. And if I live in a temperate climate, that might make the difference between me surviving and if it was 100 years ago, 200 years ago, dying. That difference of understanding the seasons. The patterns and rhythms of the heartbeat of our universe. Basically, we're going to start to see that there are lots of patterns that we can identify with, and how the universe basically is on a cyclic pattern, basically sine waves. So this is the planetary rhythms that we can map all of our planets as oscillating around the sun over a rhythm of 100 milestones, okay, or years. Geologic rhythms, what happened in the past gives us good indications for it, whether it's scientists looking at stones to generate carbon readings and or ice core samples to find out what is going on. We have this climatic rhythms where we have ice ages, little ice ages, big ice ages, and see what happens. That gives us basically areas or regions of the world where we can understand, like the seed pack. What area do you live in, so that you can figure out when to plant that seed appropriately for that particular climate. Seasonals, rhythms, and comes to patterns are to do with order, with design, and with structure. So why does nature create patterns? Why does it keep replicating these cyclic patterns? And it's the design, it's nature, and that's to do with your order and your structure. So when we make our design, our master pattern, or our master plan, at the end of class, we're going to demonstrate what our design looks like at the end of, say, 10 years. So when your design is complete in the 10-year or climax condition, that is the pattern. So what you see is a pattern. You can only see the pattern, and a pattern is only defined by its edges. If there's no edges, it's just blank space. Okay? So we have to learn how to make patterns to define edge, and the pattern and the edge is our plan. So the egg shape, the leading edge of growth, is the symbol of permaculture. It's also the symbol of Raktamachat's logo. You have it on your hand, and we can even see this pattern formed in geologic formations of rock forming. So we're going to notice that these patterns, because they convey energy, are found in all kind of different systems, whether we see the same pattern in a person as we see in a rock. Okay, how does that work? We want to try to work through why these patterns are doing it and what does that growth convey. This one is known as movement and rebirth. So a fish is the same shape as wheat. And did you know that wheat can swim? It swims in the air. So the wheat changes its direction in response to the force of wind in order to counteract the wind. So it's functionally utilizing Bernoulli's principle of aerodynamics, swimming into the wind to counteract the force of the wind so it doesn't fall over. And you know, a fish, actually, how do you think salmon really get upstream, guys? Do you think they really flip their tail that fast and that's what makes them do that? Or do they actually use the force, just like a sailboat? The force of the water coming turns the tail, as we see, creates a low pressure and propels it forward, just like a sailboat sailing into the wind, or what we call tacking. So the fish tacks, the sailboat tacks, right? The wheat tacks. I wonder how they all three do the same thing, but in different ways. This is what we want to look into. We can even get into the concept of looking to nature, observing nature, and seeing that water in nature, we don't have a lot of pollutionary issues in natural environments. But why? Why doesn't the water become stagnant? Why doesn't the water become polluted? Well, when we see a river, we can look and, wow, it seems that the river always has this sinuous nature. It always has rocks strategically placed in these places to make these nice eddies and vortexes. And when water goes through a vortex and it spins, it oxygenates the outside edge of the water to a really high state, which that oxygen is so high, like if we swig on, what is that stuff we use for our teeth? Hydrogen peroxide? Wow, it gets to an oxygen level of hydrogen peroxide and it kills the bacteria. What's really strange though, is that we would appreciate that if something was going through a vortex and spinning, it should create a lot of friction, right? Temperature should increase, but it doesn't. Water's temperature doesn't increase when it goes through a vortex. It actually decreases. Wow. Science still doesn't have a handle on that one, guys. Reaches a state of 7 degrees Celsius. That's why the river underneath doesn't freeze all the way, just the top. Water's still running. A gentleman, an Austrian forester, postulated on that and wrote a book in the 1600s. Said water was alive. Said he believed it was a living entity and that it had the ability to cleanse itself, right? And it had a natural concept. And through there, people were not able to, at that time, test his concepts of the embodied energy of water or the highest embodied energy of water. But now we can. So we can test water and see the energy in it. So we find that the highest embodied energy of water is after it's gone through a vortex at 7 degrees Celsius. Well, there people say, let's mimic that. So if I'm going to drink this energy, what temperature should I drink it at? And should it be oxygenated or should it have been sitting in a deoxygenated standpoint? Which one would be better for you? This is a real big problem with, we have the East. The East would say, never drink anything cold. But of course, for 28 million years, assume that we were drinking from rivers. Rivers, even in the warmest of place, are not warm water. Yeah? So this is an interesting thing that the temperature actually would be cooler and it should be vitalized or oxygenated. And now you can buy machines that will do that. So here's an egg. Interesting choice of form. You push the top, it spins a vortex. You take out the water, highly oxygenated and at a cool temperature. Or you can purchase these little nice ones and spin them yourselves. So that's a thing where someone's observing nature and they're trying to create a pattern or a system or to replicate what they find in nature. This is called the spoke and wheel. It's a natural building pattern. So if we want to build a round house, okay, so this shape that we saw originate around the world in habitable structures and different cultures, I have to question, since it's the same pattern as a flower, did the flower decide to copy the house? Or did somebody figure out that if they took a flower and turned it over, it'd make a hat for the house? And did they copy the flower? They look the same. Habitat following function or form following function. So the habitat follows the form found in nature. This is called a 16-sided roundhouse. We have 16 sides. The outside gives me a flat place to mount my window, right? The inside is curved. So I have the inside being round and the outside edges able to mount windows. So really nice structure. We see them again around the world in different cultures that develop this. And we also see the same structure, again, found in flowers. We can find webs throughout nature, different animals, also clay. If we watch the cracking of clay, it cracks into a web. We can utilize that in what we call web application. We utilize that to describe the animal or plant hierarchical systems, okay, or the soil food web. We can use that to mind map the way we think. So this is a nice way to see the earth and your belief systems as attached from personalized to depersonalized around the earth. And if we were utilizing bamboo, which we could even say that bamboo is a celebration of nature in the way that people are making geometric forms, but functionally the buckyballs or a geometric dome is a web application. It's the strength. And it's interesting that the largest internal volume with the least amount of materials in the world is a geometric dome. So if you want to build a house and you want to get a volume on the Jeep, well, there you go. That's the cheapest one there is. So Bill Mollison attempted, which is a really big thing, and I think this is probably where the other classes just kind of stop. They look at this and go, oh man, that's too far out there. I don't know how to talk about that. Well, he called this the general core model in the designer's manual, but some people may have seen it as the torus. The torus is the underlining shape of the magnetic field in the universe that we live in. The universe is actually a torus. A torus is actually a donut or a conical shape. The Earth's magnetic field also goes through a torus. If we see the apple core, a core of an apple is a torus. So we see that shape all the time. Bill then said that in this postulate that he was trying to do, he said that he thought that he could overlay every natural pattern that we can see. So we're going to go through all the patterns over a torus. So he said the torus was the core pattern of the universe. And the core pattern of the universe produces the other patterns. So the other patterns are offshoots of this. You even can take this if you so choose, because energy, everything is energy. Where does the energy separate? We're all energy. We're all connected in some way. So here is a core permaculture process. So if I wanted to take the torus and to think about permaculture or a design process, and this is just one way to look at it, I have ethical intentions. So this morning we talked about our ethics that help to guide what we're going to do. Because as designers, our ethics help us to not make bad designs or over good designs. So I can vision. You need to have a vision for what's your design. What do you want to do? What is your vision? Okay? I helped you with the wording of what is your lifestyle goals? What lifestyle do you want to live? It's kind of like a vision. Vision that lifestyle, living that lifestyle. At which time we have to do assessment. So we can take our vision and we push it through the torus. The assessment is like a sieve. I have to say, okay, I might want to do this, but do I have money? I want to do this, but where am I going to get time? Do I have the skills? So maybe I can write, I don't have enough skills. I can go to learn, I can skill up. So through my assessment, if I can get through, yes, I can assess that I have the capacity to do that vision. I can push it back through and I can look at conceptual planning. So how would I conceptualize making this plan come to reality? Again, I have to push that through another sieve that you could call master planning. And anytime I get pushed back and forth through my thought process of, wow, I didn't realize I need that. Let me go back, make sure that works so I can come back over here. Of course, that makes an infinity symbol. So that's a torus. With a torus over a torus within a torus. You three-dimensionally can draw that actually. Some people would like to call that the seed of life. And, but if we were to read that, I could call it TAPO, which is nice acronyms. Acronyms make everything better, right? Thoughtful and protracted observation. So when I take thoughtful and protracted observation, that's the sieve to make sure that I am doing my things right. This is a process of understanding you're not going to be right the first time. You need to go through a process and you need to give yourself options. So option A, B, or C, and then I can look at which one's best, and then I can move on from that. Sometimes I get stuck and I need to go back and re-look at how I got stuck. This is an organic way of looking at a decision-making process. So this brings us to modern science. It may have been much better if Newton had contemplated how the apple got up there in the first place instead of trying to decide if there's gravity, because as far as I know right now, no one can prove that. You can't mathematically prove gravity. So you can tell me that you feel gravity, and I said, well, how exactly do you feel it? Okay, so we know things fall. Don't exactly know why. We could say, well, that's because the core of the Earth, but it doesn't really work out that way. Okay, so it doesn't really have enough stabilization. What's making that happen? Who knows? But why is there an apple? And why is the apple this shape? Why is an apple red? Why does it taste so good, right? How did a seed get there in the first place? Did the seed come first or the apple tree? How's that work? This aspect of looking back to core nature and how nature works at a more core level may be more important than looking at how these non-physical aspects of nature are. And now someday we'll get there, and wouldn't it be great if we know that? But it might be better if we actually know more about the apple tree in the first place. Because if you actually took the total thing that we know about that, we don't know much. Nobody seems to want to study that. So, So there's your core model, looks like a tree.